Okay, now we move on to part three of this series on the Black Scholes model. So here we'll be primarily covering a couple of questions which are there in the end of chapter on Black Scholes model on John Hull's textbook on options and derivatives. So let's get started. So the first question is that the volatility of a stock price is 30%, which means sigma is 30%. What is the standard deviation of the percentage price change in one trading day? Now, assuming that there are 252 trading days in a year and sigma is 30%, so delta of t will be square root of 1 by 252, which works out to 0.0629. So the standard deviation for one day will be zero point 0.3 into 0.0629, which is 1.88 percentage. Now, this is an important aspect to remember because questions of this nature typically come in these risk management multiple choice examination. Second question is where you have to calculate the price of a 3-month European put option. The stock is non-dividend paying with a strike price K of 50 and current spot price S of 50, and risk-free rate is 10% and volatility, which is sigma, is 30%. So what I've done is I've kind of put this into an Excel sheet, and the output is what is embedded over here. So you've got the stock price 50, K is 50, sigma is 30%, risk-free rate R is 10%, time is 0.25, which is 3 by 12, and dividend is 0%. So if you calculate D1 using the formula of the Black Scholes equation, you get a value of minus 0.2417. NN of minus D1, because this happens to be a put option, works out to 0.4045. You can use the Excel function normdist and impose the value of D1, which you have earlier calculated, which is 0.2417 negative. Likewise, you can get the value of D2, which is 0.4639. So plug it into the put formula, you get a current put value of $2.376. So what I would urge you is that you create an Excel sheet with these formulas and try to work out this yourself to see if you are arriving at the right answer. That will help you to remember the formula as you work through the worksheet. Let's take the next example. Stock price is currently $40. Expected return is 15% by a particular investor. Sigma is 25%. What is the probability distribution for the rate of return with continuous compounding over a 2-year period? So mean is mu minus sigma square by 2. Standard deviation will be sigma by square root of t. And the distribution we know is given by mean comma standard deviation, which is nothing but mu minus sigma square by 2 comma sigma by square root of t. So plug in these formulas, you know mu is 0.15 minus 0.25 square by 2 comma standard deviation is 0.25 by square root of t, which is square root of 2 because it's over a 2-year period. So the distribution which you get has a mean of 11.87 and the standard deviation of 17.68. And that's the answer. So basically the requirement was to calculate the probability distribution. So when you calculate the probability distribution, which is defined by the mean and standard deviation, these are the values which you get. Let's move on to the next example. So here you have a stock price following a Brownian motion with an expected return mu of 16%, sigma is 35%, and S, which is the current price is 0, is $38. What is the probability that a European call option on the stock with an exercise price of $40 and a maturity date in 6 months will be exercised? So let's look at the A formula first. So log normal of S0 is 3.638, which is nothing but log normal of the current stock price, which is $38. Mu minus sigma square by 2 works out to 0.099. So you know mu, which is 0.16, and you know sigma, which is 0.35. So above times t equal to zero point 0.5, which is what you need to multiply mu minus sigma square by 2 times t works out to 0.049. And the sum of these 1 plus 3 is 3.687, and you get a value of, with a standard deviation of square root of now, point 0.5, which is basically what you found in point number 5, which is 0.247. Now you know that the z value is nothing but x minus mu over sigma, which is log normal of 40, which is 3.689. So 3.689 minus 3.687 by 0.247, which is 0.008. Plug it into the norm function and you get a 0.503 value. So probability of the price being less than $40 is 0.503. So probability that is greater than 40 would be 1 minus 0.503, which is 0.497. So probability that the put will be executed is 0.503, which is the probability that the price is less than $40. So just kind of digest how this calculation has worked, and probably what I would suggest is you plug this into a worksheet and see how you get the values yourself, because this is an interesting problem to work out. Now, portfolio manager announces that the average return for each year is 20%. In what respect is this statement misleading? Now, we know that geometric mean is always less than the arithmetic mean. So return of the period would have varied, and in some cases might have been negative as well. So if you calculate a total return using geometric mean, you would get a more realistic figure, which is less than what you would have if you had used arithmetic mean for calculation. Now, this is another interesting example. Price of a European call option needs to be determined. Stock price is 52, strike price is 50, risk-free rate is 12%, volatility is 30%, time to maturity is 3 months. So S is 50, S0 is 52, K is 50, T is 0.25, which is 3 by 12, compounded risk-free rate RF is 12%, standard deviation is 30%. So value of a call, you plug in into the Black Scholes module log normal of S by K plus R minus plus sigma square by 2 times T divided by sigma square root of T. You should get the value of D1 and then D2, and using those you can plug it into the Black Scholes equation. You'll get a value of call of 0.50574 and a put value of 1.5797. There are several calculators which are available on the internet, but what I would suggest is you first manually calculate it yourself, probably on Excel, and then check whether your answer is correct by using the calculators which are available. Similar to the earlier problem, you have to determine the price of a put option. S0 is 69, strike price is 70, risk-free rate is this, and time is 6 months, which is zero point 0.5. Same way, like what we have done earlier, you can work out the calculation. You'll get the value of the call as 7.12 and value of the put as 6.40. So here you have an American call option. Stock price is $70. Time to maturity is 8 months. Risk-free rate is 10%. Exercise price is 65. Volatility is 32%. Now a dividend of $1 is expected after 3 months and again after 6 months. So this is during the life of the option. So it's never be optimal to exercise the option on either of the two dividend dates. So call option exercise time Tn, the investor gets S of Tn minus K, which we know ST minus K. not exercise, the price will drop to ST minus DN, which is the amount of dividend, minus K times e raised to the power of RT minus N, which is the remaining time to maturity. So it will be optimal to exercise if ST minus Dn minus K e raised to the power of minus R times T minus Dn is greater than ST minus K. So on the first dividend date, D1 is zero point 0.1 and T2 minus T1 is 3 minus 0, because the first dividend comes after 3 months, which is 0.25. Second dividend, it is 8 minus 6, which is 2 months. So right hand side of the equation works out to 65 times 1 minus exponential of zero point 0.1 times 0.17, which is 1.09. So in both cases, the dn is less than the right hand side, which is k times 1 minus e raised to the power minus rt minus dn. So it is not optimal to exercise the option. Similar to the earlier example, I would suggest you run through the solution which I have given over here. Try to work it out without actually referring to the previous worksheet, and see how you're getting the answer which is being given over here. So if the volatility of a stock is 18%, estimate the standard deviation percentage 1 day, 1 week, and 1 month. So 1 day is 0.004. Remember the first question in this presentation, use the same formula. So 1 week means 1 by 52, 1 day means 1 by 252, and 1 month means 1 by 12. So if you plug it into these that formula, sigma times square root of t, you'll get these answers, which is 0.004, 0.028, 0.083 times sigma, which is 18%. So you'll get 1.14%, 3 and 5.02%. This is a repeat of an earlier problem which we solved. So you can always cross refer to that. Stock price is $50, expected return is 18%, volatility is 30%. So you have to find the probability distribution, which is mu comma sigma in 2 years, and calculate the mean and standard deviation of the distribution. So mu is 18%, we know sigma is 30%. So mean mu minus sigma square by 2, and standard deviation is sigma by square root of t. So you get 13.5%, which is nothing but 18% minus 0.3% divided by 2, and standard deviation will be zero point 0.3 divided by square root of t, which is square root of 2. So you get 21.21%. Probability distribution has the mean of 13.5% and 21.21%. With a 95% confidence, you can say return will be between 13.5 plus 1.96, which is 1.96 standard deviations for a 95% confidence, times sigma, which is 21.21%, and this. So with the 95% confidence, you can say that the return will be between minus 28% and plus 55%. So that pretty much is most of the questions which we've covered on the end of chapter of Hull's book on Black Scholes. I hope these questions give you a good flavor on the application of the Black Scholes model and how various numbers are used for calculation. Try to remember the formulae for D1, D2, value of a call and value of a put, and that should pretty much suffice insofar as your approach to any of the risk management examinations is concerned. Thank you.